I make the definitive assertion that modern climate scientists, the ones who make up the 97% consensus, they have not made any mathematical errors. They have also not inadequately or inaccurately stated their consensus and conclusion, because they all start with the same data, they all look at different things here, different things there, but they all trying to build the big picture. They all start with the same numbers, and they don't make any math errors, and so therefore they do all have a consensus. And yet, despite the fact that they have not made any mathematical errors and they have adequately stated their consensus, every single climate study is flawed, every last one. And let's catch you guys up to where we can have a full discussion to where climate scientists and laymen anywhere will understand exactly why this slide is true. So we are going to talk about climate science simplified. That's us catching up. We're going to talk a lot about space weather forcing of the terrestrial climate and weather. And we're going to be talking a little bit about volcanic forcing at the end as well. So, this truly is a accurate way, very, arguably oversimplified, true, but this is a 100% accurate way to write the equation for climate change. You have what the Earth is naturally doing, you have what humans are doing, and the total of that is the total climate change. Very, very simple. When it comes to natural variability, that's things like the sun, things like albedo of the planet, that's how much light gets reflected off of white clouds or ice versus gets absorbed and integrated and transformed into heat eventually. Volcanoes in how they block out sunlight. And, of course, Milankovitch cycles, precession, in both axial and the apsidal precession that we've heard about recently. So all of these things would be part of natural variability. The human changes to the planet are mostly chemical in terms of carbon emissions, things like that, deforestation, urban heat islands, and other smaller localized things like that. And true enough, if you get all of these pieces correct, then everything will work. But the problem is with what I've circled there at the bottom left. If we don't have the natural variability portion of this equation down firm, then by definition we can't get the human changes portion correct. And so, solar forcing, according to the IPCC, our government, and including all CMIPs, which would be the world climate models. And this goes all the way back to 1979. All that solar forcing is, and many of you know this, is 0.1% ultraviolet changes over the 11-year solar cycle. That is not an erroneous figure. But as I change the color of the background sun and only the bottom line, it is egregiously under-inclusive. And here's why. This is the total solar irradiance. It's based on a wide variety of different wavelengths in the ultraviolet and peaking up into the extreme ultraviolet range. It does not touch radio waves, microwaves, infrared, or X-ray solar flares. And so we saw from Dr. Tinsley, and many of you know, that indeed total solar irradiance pretty much follows the sunspot cycle. During the sunspot minimum, it's low. During the sunspot maximum, it's high. Now, indeed, the largest dips on here are eclipses and the Venus transit. But that's the largest 4 on here. All of these other drops down are major solar storms. Now, how does that make sense? How does a major solar storm show up as a drop in solar forcing? It's because this is only looking at ultraviolet light. And so you might remember in September of 2017, we had the X9 solar flare. One went off over the limb that may have been even larger. And it was the largest solar flare in 12 years. Well, this is I don't know if you can see the dates down there at the bottom, but this is what happened in the official solar climate forcing charts when we had the largest solar outburst in 12 years. Because in fact, a lot of the energy that was used to put out ultraviolet light was transformed to X-ray, which again is not in the total solar irradiance. And you have a slight solar dimming because there's a massive coronal mass ejection, and those particles stand between us and the sun and block a tiny fraction of light. And so here we have essentially a drop that is larger than the drop you'd expect from sunspot maximum to sunspot minimum, occurring in a couple of days during the strongest solar storm in 12 years. There's a real disconnect in logic there, and you don't need a physics degree to see that. Because while indeed during these phenomenal solar events, ultraviolet does dip a little bit, much to the delight of climate scientists. But in X-rays, we see 100 to 100,000 times increase over minutes to hours. Solar wind, phenomenal increases. Again, we're talking orders of magnitude. In terms of the energetic particle flux, specifically the protons, the high energy protons, those can have 10 to 1,000 times increase. It's difficult to say exactly how much of an effect those have on the ionosphere potential that translated or transformed down into the global electric circuit and things like that. Now, despite everything you see up there at the top, the official solar heating influence of the event is in the negative. So here we have phenomenal increases. These are the biggest deliveries of energy from the sun to Earth, and they show up as 0.05 to 0.3% decreases in the amount of energy the sun has given us, because they only look at total solar irradiance. And so you come back to this simple equation and you realize, okay, well, how do we go about fixing something like this? And it turns out that there might be some light on the horizon there. But before we get to that, we have to examine just how damaging this is, because when you hear 0.05 to 0.3% decrease, it doesn't sound like that much. You might even think, oh, well, I wonder if that's enough to really make the point. Well, it results in climate change, and you can't account for it in the natural variability because you're only looking at TSI. So you have all of that real forcing, and where do you have to put it in the equation? You have to put it on the human changes. So true enough, the actual difference is attributed to human-induced global warming. Not just what the sun actually does, but the false decrease that is shown in the actual solar input. And so what that means is, for the history of climate science, what is more than 140 years of solar flares and CMEs pounding our planet, not just missing, not just showing up as negative solar energy, but they are included on the human side of that equation. By definition, this is a big problem. And then you realize that the problem, when you're looking at the period of global warming, might be an even more extreme case. This paper came out, and it's been recited a number of times, although I don't think any of the citations really do anything to further the point made in the original work, and none of the original authors are in the subsequent ones, so I figured I'd go back to where it actually came from. But during this period of global warming, basically the 30s, 40s kicking in, 50s, 60s, 70s, 80s, there was twice as many CMEs as there were now as we're coming out of grand solar maximum, and as there were 100 years ago at the start of the 1900s. So during that period of global warming, the numbers were probably closer to the 1,000x, the 10,000x. So just once again, kind of hold this in your mind, that when this happens, when there's a major solar storm, all of the real forcing of it gets added to human total, and then the icing on the cake is this false modulation downward of the sun, which also has to get added into human totals because there's no actual downward modulation of the climate. It's an upward modulation. We have input of energy. So that negative solar forcing has to be accounted for doubly for human changes. So this is the nice, neat little box and picture of climate science. If you're a mainstream climate scientist, you have the 0.1% varying over the 11-year cycle top-down solar forcing. It's a thermal coupling that starts at the stratosphere and slowly meanders its way down. And everything else that the sun does counts as human forcing. Well, let's take a look at what we can learn from the 600 peer-reviewed papers since 2010. And this is where I'm sort of going to pick up with the most recent stuff from where Dr. Tinsley left off. And so we know that there's not just this 0.1% top-down solar forcing in the thermal coupling realm, but there are these oscillation and circulation modulations. Say that a bunch of times fast. And these are also thermal couplings as well. They involve much longer-term holding of that energy by the oceans and by the atmosphere, and they do involve albedo a lot more. And these are, again, our thermal couplings. These would be all the papers that show there's a relationship between the sun and El Nino or La Nina, the sun and North Atlantic oscillation, like Dr. Brian Tinsley was showing us. Northern annular mode, southern annular mode, even the quasi-biennial oscillation, pretty much any of these you can think of, they have found these signatures of the solar cycle within these long-term, and when I say long-term, the El Nino cycles, North Atlantic oscillations. These cycles usually last somewhere between, about a year to 3 years. 3 years would be kind of extreme. But there's also this total vertical column modulation, and this is an electromagnetic coupling, and that is wholly missed by most of the models. It is difficult, although frustrating, to respond to the excuse for why the oscillation and circulation modulation is not included in the climate models, because they say, well, that's just kind of a stirring of the pot. That's mixing up what's already in there. We just want to know how much energy is getting in and then taking the global temperature. And as frustrating and almost certainly wrong of a way of looking at Earth as that is, I don't have a good argument for it. But there is no good argument for ignoring this total vertical column modulation. And so just to give you guys an idea of what this looks like. So this is mainstream climate science with natural variability from the sun. We have ultraviolet that hits the upper atmosphere and middle atmosphere. It slowly trickles down through global heating, and this is a direct thermal absorption. Now, that little block right there is not going to change. I've just blacked out everything else. And so I'm going to take away the black, realize that the ultraviolet portion is still going to stay there. And so this is what these 600 papers actually show us. That we have, from the cosmic rays and the sun, we have a wide, very broad picture of forcing, particle-wise, in terms of electromagnetic fields, and yes, in terms of the electromagnetic waves as well. And so running down this really quickly, over on the left side we have the cosmic rays. Those would be the primary source of the energetic particles that actually make it down into the atmosphere, although the sun does play a role in that as well, especially in those massive events. When it comes to the cosmic rays, or the electromagnetic particles, you can really break these up into the super high energy cosmic nuclei that are created in supernova. Those are the ones that can actually make it down into the mantle. Those are the ones that are absorbed by the silica-rich magma, and we've now seen 3 papers on how cosmic rays trigger explosive volcanic eruptions. The majority of the cosmic rays are really just higher energy protons and some electrons, and those are mostly integrating with the magnetosphere, ionosphere, and performing those breakout cascades when they make it to the upper atmosphere. And then, of course, we have the solar wind, which Dr. Tinsley was talking about quite a bit, and that also directly electromagnetically couples with the magnetosphere and ionosphere. And below there in the yellow, you can see that there's that vertical column pressure. And we're going to come back to that. Hopefully some of you are already getting a picture of what that means if you can picture when we pull the wind maps, and you can see there really are these circular column cells of unified wind motion. Looking at the electromagnetic waves, there's another side to the right of the ultraviolet. And that would be the X-ray radiation, which is also not included in the climate models, but this is absorbed directly in the ionosphere and upper atmosphere, and that plays a role into the global electric circuit because the global electric circuit ceiling is the ionosphere, and it has multiple floors, so to speak, at different cloud layers, at the surface, and at a couple of different layers of the crust as well. And so that X-ray radiation, even though it is waveform and it's very much thermally absorbed up at the top, it also has a direct tie-in to the global electric circuit. And so this would be what would be down below here, because the chart doesn't just end right here. So let's take these two columns over on the right and come down to the upper level patterns that you really see when it comes to the electromagnetic wave modulation. Specifically the polar vortex events and the jet streams. The jet streams are mostly affected by the absorption of electromagnetic frequencies, mostly X-rays, and those also affect the polar vortices, but also the particles. That would be the X, P, E, N, protons, electrons, neutrons, things like that. And what we see, it's very, very simple. When the sun is blasting hard and giving us a lot of this energy, they're able to take in a lot of this energy. It's a positive correlation. They stay strong, they stay flat, they stay tight. So when the sun is really blasting out, the jet streams are relatively flat. The polar vortex is tight and flat up at the poles. When we lack the solar energy, we start to get this wavy jet stream, and sometimes it can actually wave too hard and lock up on itself in what they call the omega jet stream block. If you guys have heard of the omega block, the omega block. And when it happens with the polar vortex, it loosens and becomes really wavy, and when it becomes too wavy, we get these polar vortex events that come down into the States and over Europe and really cause these snow and cold records to fall by the dozens, as we've seen. And of course, so high solar activity is going to mean warmer weather, less extreme weather in terms of what the jets are causing. Weak solar activity means colder events and more extreme precipitation events in terms of the jet stream blocking. That's how you get those areas where it basically just rains for days and days, and it seems like the low pressure cell is stuck there and is just spinning in place. Happened a couple of times in 2011, pretty good. So if you could take the previous cosmic ray column on the left and you could break that down, so we can actually see that there are in fact three sources of cosmic rays. There are the cosmic ray nuclei from the galaxy and beyond. There are the solar energetic particles, quite obviously from the sun. And then there are the relativistic electrons from Earth's own Van Allen torus. So like when we get a strong CME compressing the magnetosphere. And it's known that it pushes the Van Allen belts down into the upper atmosphere. We've seen that happen. We've detected it. That's also where the relativistic electrons, some at the same kind of energy levels as some cosmic rays, are penetrating down through the atmosphere as well. As we heard from Dr. Tinsley, and I'll just sort of quickly say it again here, there's a couple of ways that they affect clouds, and they both sort of point to more clouds, and that is the direct creation, really, of cloud condensation nuclei out of existing particles that might already be cloud condensation nuclei if you've given them enough time, but you whack them with a cosmic ray, and all of a sudden they're attracting dust and water vapor and other things that like electricity. And the other thing it does is it ionizes the ambient air if it doesn't directly hit one of those aerosols, such that that ionized air is ready to go find those aerosols. And they are attracting water vapor, and they are attracting dust, just like the Swiffer sweeper works in your home. It's the same, it's basic principle between the dust and the vapor up there. And so I actually like the way Dr. Tinsley put it much better than this, but it helps particle nucleation, and it helps the particle ionization up there. And so let's keep going down the list here. This graphic that we have down there is something that most people don't think about in terms of the weather. Even those of you who really geek out on those wind maps with me, where you can really see how from the surface all the air is sucking into the low. At the 800 HPA level, it's just a column. And then up at the jet stream, it's expelling there, and you can see the full column of the atmosphere. Well, there's also the Hadley cells, the Ferrel cells, and the polar cells. Now, there's not a ton of direct literature on solar effect of the Ferrel cells. There's a pretty good argument to suggest that they basically do what the Hadley polar cells and the jets tell it to do in terms of where it is and how strong it is. But we do know from a lot of the papers, when we get high solar activity, it pushes the Hadley cells towards the polar region. This, in turn, pushes the subtropical jet and the polar jets towards the polar region, which is one of the reasons why, whether you're looking at the intertropical convergence zone or the jet stream divide of hot and cold air, you get more of the tropical heat spread to mid-latitudes during the high solar activity when the Hadley cells are trying to expand because they're taking in more of that energy and they're pushing everything a bit towards the poles. And the polar cells, this is really where you have to remember that there are these Birkeland sheets, and the way the European Space Agency drew that, you can't call them Birkeland currents, you have to call them Birkeland sheets. The way they basically come in layers right there around the auroral circle. These are the things that are really interacting with not only the total vertical column of pressure, but the polar cells themselves. And so you can see on the left what basically I show up in the atmosphere. And by the way, all I did was reverse the color from NASA's graph. That is NASA's graph. I just reversed the color because I think it's prettier. So we have that motion, but it's not just a motion in place. You see the arrows that are actually on the planet, how they're sort of going in a helix around the world. And so you have to think of that full three-dimensional motion when you're thinking about this. So we have both the motion that you see on, up in the atmosphere. We also have this corkscrewing motion across the planet, and they corkscrew opposite one another, in terms of Ferrel, polar, and the Ferrel and the Hadley cells. And then in addition to these motions, we have the total vertical column of the air that's spinning like this in lows or spinning the other way coming down in the highs. I mentioned the oscillation and circulation modulation. Another way to say that is the oscillations in the modes, the northern annular mode, southern annular mode. This one is phenomenally easy. We'll start on the right with the quasi-biennial oscillation. High solar activity, decreased effects of the QBO. Low solar activity, increased effects of the QBO. Probably not due to necessarily the sun, but its modulation of cosmic rays. The much more important part of this is there is virtually unanimous agreement among the papers that are out there that the positive / negative phase forcing of high / low solar activity on all of these oscillations, ENSO, NAO, PDO, AMO, NAM, SAM, all of them, it's direct. High solar activity is going to push it towards the positive phase. Low solar activity pushes it towards the negative phase. It is not controlling, but it is also not a coincidence either that the weak El Niños occur when there's low solar activity and the strong El Niños occur during high solar activity. And the opposite for the La Niñas. It's not as though the solar cycle is going to command that El Niños stick around for 4.5, 5 years and La Niña stick around for 4.5, 5 years. Those are going to have their own oscillation. But is it a strong El Niño, a weak El Niño? Why don't you ask the sun what it's going to be? Probably knows better than a lot of statistics that we might otherwise garner here on the planet. So again, mainstream climate science, reality. So a few more notes on some of these things. 0.1% top-down thermal forcing is minimal. It is 0.1% over the solar cycle, and it is slow. The oscillation and circulation modulation is so robust that there is a very wide agreement. Not only are Dr. Tinsley's papers on the North Atlantic Oscillation convincing, but Dr. Leslie Gray's are phenomenally convincing as well. Considerable effects there, but again, those are slow and many of those lag. So for example, I think on the El Nino and La Nina, there's a 1 to 3 year lag from the peak of the sunspots or the minimum of the sunspots to when you actually see it. But when we talk about that total vertical column modulation, that electromagnetic coupling, it is strong and it is immediate. You guys might remember from the book, it was 3 times confirmed. Some of the ground readings were changing as the solar wind was changing. It is immediate, pretty much, like within minutes. No 1 to 3 year time lag like with El Nino. No, well, if you're talking about grand solar maximum versus grand solar minimum, no potentially 30-year heat lag coming back out of the ocean. This is strong. This is immediate. It's not just cloud cover. Dr. Tinsley has some work on basically immediate pressure effects down at the ground as well. And this makes sense because it's a global electric circuit. And so again, 140 years of solar flares and CMEs show up as a decrease in total solar irradiance, in solar forcing of the terrestrial climate, and they get added to the human total. Not just that decrease that's not really there, and so we have to make up for it because we don't see a decrease in the actual global temperature. But anything the sun is actually doing, that huge dump of energy to Earth, also gets added to the human forcing totals. Now, here cometh CMIP6, and for the first time ever, cosmic rays and medium energy electrons are going to be included. For the first time, particle forcing is going to be included in climate models. Right? You know, when they first announced this, they did not give the option to download the data without particle forcing. I don't know if it was a month or 2 months, but it was not more than 3 months after posting this. They offered the data with all of the particle forcing removed. Just here's the updated UV, TSI, etc. Not even the X-rays, though. Still no X-rays allowed. There have been a great number of climate scientists who have attempted to use CMIP6, but they have all attempted to use it with the without particle forcing. And I think it's probably pretty clear, and I've only done this with 2 papers so far. I do need a lot of time to do it. But the good thing about climate science is that they have made their work very reproducible, such that if you get new numbers, all you got to do is just plug the new numbers in and see what it does to the equation. And in the papers that I've done so far, adding just the medium energy electrons, which by the way is still egregiously under-inclusive, the potential effect of CO2 goes to 0 almost instantly. And I'm sure that some climate scientists went and they tried to use this data. They saw what was going to happen, and they went back and asked them for it without particle forcing. Because it was not the plan. If you go back and you read Mathis et al., where this came from, Mathis et al. 2017, there was no plan to offer this without particle forcing. It's preposterous. The whole point of this was to get the sun correct. The best I can tell, you know, the next round of IPCC stuff is underway and it's going. They are not using the particle forcing. So, at least 6 more years of bad science, of policies driven by incomplete science and politics more than anything else. At some point, you know, you can't really blame them too much. Who here among you could say that you would definitively be the first one to actually use this data and come out and say, we were wrong about global warming? There's actually kind of an answer to that. Did you guys see we have to rethink everything we know about climate change, that team from the University of Israel in Princeton, talking about the clouds and how they are vastly underrepresented in their cooling potential in all of the CMIPs. Nobody's cited their work either. I guess I'm going to just choose to believe that they're jealous that they come from Princeton, and they're just jealous. That's all I can come up with. But so this global electric circuit, and I showed the Hadley cells in the motion. Obviously, I would love to have the graphical skills to show this as a helix, as it appropriately is, as it follows the wind, as all electromagnetic motion is. But hopefully you get the idea. The current comes down in fair weather high pressure, goes back up in not just out of the low pressure, but all along that line that comes, one of the arms that comes out of a low pressure cell where the winds are crashing together, and you basically get a line of storms. In fact, that's how most tornadoes form in the U.S. They don't form in the circle of the low. They form off the tail that comes off, that converging wind area. All along those areas, all along those thunderstorm regions, the current's going back up and returning to the ionosphere. And so another thing that they will eventually, once they get over the gravity of the cosmic rays and the particle forcing, and they expand particle forcing to include high energy protons and other things like that. I'm glad somebody got that. They might want to think about the effect of electric current going through a resistive atmosphere in terms of heating. Because I asked a couple of climate scientists, well, how much of the global electric circuit resistive heating in the atmosphere do you take into account? And the answer is there is none. What? Well, there's none in the models. So I don't know which one of those top two equations somebody's eventually going to want to use, but all the information is there to figure out exactly how much heat is caused by the electric currents of the global electric circuit. Somebody, not me. So let's move on to another little thing here. Data selection matters. And no, I'm not just referring to everything I was just talking about for the last 40 minutes. Good God. So let's take a look at some data selection and where it really matters here. So, climate.gov. So we're going to actually look down there where, in the bottom panel there, where they have the spring snow cover. And indeed, spring snow cover is on the decline. I've gone ahead and zoomed in on this here, and I've even gone ahead and I've drawn a regression line for you there. The problem is, and as this comes from the Rutgers Snow Lab, obviously Rutgers University, this is their graph for the winter snow extent, and this is their graph for the fall snow extent. Yeah, it's true. We have less snow in the spring. We have more in the winter. We have more in the fall. Data selection really matters. Now, hopefully we all have a good enough memory to realize you all just saw this chart not long ago. This is how climate science determines what high volcanic forcing is versus what low volcanic forcing is. The problem is that this data selection does not tell you what high volcanic forcing is, because this entire timeline right here is contained within the little green bars over there on the right in the paleoclimate data. It's always amazing. They have this data that goes back, and yet climate science won't use it. So we have very, very real volcanic forcing back in the day, if I can put it that way, back into deep antiquity, as Dr. Peratt would put it. And literally, take a look at this, that little bit down there on the right. That's this right here. That's all that is. And so this does not give us an adequate representation whatsoever of what high versus low volcanic forcing is. In fact, things can get a lot realer. I've lined up some isotope records here with this, and of course you've got the medieval warm period, a little more than 1,000 years ago. We had the mini ice age, or the little ice age, whatever you want to call it, that occurred in the wake of that high volcanic forcing, and in the wake of not only the Maunder minimum of the 1600s. But a lot of people fail to remember the previous grand solar cycle was a dud entirely. Yeah, the Maunder minimum was the low point of that, but the entire 400 years before that was a dud. It was like a continuous 600, not really 600, but 400 to 500 year grand solar minimum for the most part. And of course, we see grand solar maximum rise up through the 18 and 1900s, peaking somewhere between 1950 and 2005, while we see record low stratospheric aerosols, not just in the climate era, but back through much of paleoclimate data. You might remember when Dr. Tony Phillips shared that presentation that it was only presented as an abstract at the conference, but Tony Phillips got permission to post it on his website, and it showed, just based on the visibility of the lunar eclipses, that we are indeed at a record low, pretty much, for stratospheric aerosols if you're looking over the long term. So probably the most important thing to remember is that when the sun gives us its greatest injections of energy, those injections of energy are attributed to humans. And just to add insult to injury, instead of going up and instead of just sitting flat and being missing, the sun is falsely modulated downward in climate data, and that gets added to the human forcing too. Almost anybody can understand a simple equation of climate change and how if you don't get one of them right, every single thing you think about the other one is wrong. All of it. And it's not to say that humans don't have an effect on the climate. Unless this is your first time listening to me talk, you know that the majority of time when I do this on YouTube, the first thing I say is, none of what I'm about to say means we can let people start polluting like wild. There are many more reasons to stop polluting because of our health than because of the climate. This is the air we breathe, this is the water we drink, and this is the ground in which we grow our food. From the lack of logic and from the egregious under-inclusion of the totality of space weather, every single climate science study that puts the blame on humans and does not include particle forcing should probably be thrown in the trash or unwrinkled, new numbers put in, and then see where it all comes out. And I honestly think that any climate scientist who doesn't use the particle forcing, wouldn't it be great if that paper just wasn't allowed? Just wasn't allowed in the consideration for global science models, for global climate models, for policies and things like that. All the while, we still battled pollution in the name of our health and in the name of the future of our planet and our children. It doesn't seem like it would be that hard to do. But it is a now $64 billion a year business, the business of climate change. So in all fairness, though, only a few billion of that comes in grants and science funding and projects and other things like that. So that's pretty much where I stand. I'd like to think that you guys could probably describe to just about anybody why no climate scientist in the 97% made a single math error. They were all given these constants and this data. They made no math errors. They looked around. You get that answer too? What about you? You got that answer too? Let's accurately state our consensus. They did those things, and yet every single one of those studies is flawed and wrong and under-inclusive of reality. It's a disservice to science, and it's a disservice to human progress and innovation. So, climate change. What? Okay.